All right, welcome back, everybody. Welcome to the part of the course where I give lectures, I guess. Thanks, everybody, for your presentations. Overall, very good, thank you. Hopefully you learned something, well, both, I guess, from doing your presentation and from the others. I think... every semester when I do this, I have this worry of like, oh, what if they choose some really skewed group of technologies, or I don't know, like, or all front end or all back end or something. And that never happens because you have diverse interests and there's a lot of cool things in there. So again, hopefully that overview is useful. I'm going to leave that tab open because I think I'm going to want to have a look at it once in a while as we go through here. So I want to, I guess, a little bit recap what we heard during the technology evaluation presentations. We heard about all of these things that I think roughly all of them would describe themselves as frameworks. Redux is maybe a little bit special in there. Things like Bootstrap, you might not describe them as a framework. They're kind of like a special purpose tool. GraphQL, again, a tool, probably not a whole framework, but I'm not sure I know, because I'm not really sure I know what framework means. It seems to be that people use the word framework when it's like, like you almost never write a line of code without referring back to this thing that you've imported. Well, then it's probably a framework. And if you've ever written, I'm going to focus probably mostly on the backend frameworks as I sort of talk my way through here. But if you've used those, you can write Rails, Django code or Rails code, and almost forget that Python and Ruby are the programming language. Like, you're not writing, it doesn't feel like you're writing Ruby code. It feels like you're writing Rails code, and Ruby is sort of incidental. Almost everything you write is in Rails. To the point that I think sometimes people forget. Like, I occasionally see questions online that are like, oh, I'm using, whatever, like, ASP.NET MVC. How do I X? And it's really, what, you know how to program? Like, that's just a programming task. You don't need to refer back to your web framework. You just have a little, you have to write a for loop or something. And I feel like people forget, just because everything becomes so much about the framework, you forget you're still just programming. In some of those cases, I don't know who's asking those questions. Maybe these are people who in some sense don't know how to program, right? They've learned the framework as the only programming they've ever done. You're not in that category. So I think the themes for me through these presentations, both this semester and in the past, there's problems that we're going to have when doing web development. You're going to have it in your project. I'm going to have it the next time I open up a text editor and do some web development. You're going to have it in the job or the co-op or whatever. You're not the first one to have this problem. Other people have written code to help you deal with it, to help you get over that problem. You have some choices to make. And again, in some ways, I guess the other thing that I'm not worried about when I do these presentations is, well, what if there's, how many groups did we have here? 21. What if there were 22 groups? Would we run out of topics? No, plenty of things out there. Are they any good? Well, again, I do feel like when giving these presentations, groups often feel like, or some groups at least feel, some obligation to decide that their topic is good, right? We picked Express. We have to, it has to be good, because otherwise, no. I think it's a totally reasonable conclusion from the technology evaluation. It's like, well, it's kind of annoying. I won't point at any particular, but some of these frameworks are not ones I would ever choose to actually do work. But the point is, they exist, and code that somebody else wrote and is useful and is going to solve my problem is going to be a lot easier than code that I had to write myself to do every single one of those things. So again, some of the common themes, I guess, and certainly not not an exhaustive list, but we heard about MVC many times, which, I mean, if nothing else, it's really just a way to organize your code, right? I'm going to have data to worry about and manipulate and store, and I'm going to have requests. User actions, I guess, in general, but for us, HTTP requests are going to come in. What do I do about that? And then I take my data and I take my request from the user and I shake it up and I'm going to respond somehow. And again, different frameworks use these terms a little differently and they draw arrows in different spots on their diagrams, but fundamentally, that's what's going on in all of these tools. And you don't need it, right? You don't need to put model code over here and view code over there or whatever, but it makes your code better, right? It helps you separate the logic part from the display part and the actions part. And you probably should do that. And this is a good way to sort of guide you in that direction. So most of these frameworks have, again, some concept of some of those things. And I think in my mind, it's fundamentally about how do I put my logic together so it makes sense and somebody else can read my code and whatever else. One of the things that comes up a lot in the model side is this, like, well, I have a database table and I have a class, and what I want is a row to be an object. Okay, well, that's what object relational mapping has been all about. And I guess this could be, well, I guess I've sort of said it here too, but the same kind of thing that can happen on the client side with client-side frameworks. It's data that I guess came from the database, but it enters the front end when you get it from the server as a JSON response or whatever, and you want to turn it into JavaScript objects or TypeScript objects. It's kind of the same idea. I mean, obviously the interface is very different, but it's basically, I have data that's very nice, but what I want is classes so I can get on to the programming part. And again, on both the front end and back end frameworks here, we saw a bunch of that happening. URLs to logic, dispatching or routing, depending on the framework. Again, so when that request comes in, fundamentally, it's, an HTTP request has arrived at the server. There's a path string. I probably am going to take that path string to mean something. This path points to that logic. There's a function or a class or whatever. How do I get those things together? Again, we're all going to have that problem every time there's a web thing. There's a helper there. And when I'm sending data back to the user, well, what's it going to look like? Well, it's going to look like HTML, or it's going to look like JSON, or it's going to look like, I don't know, a PDF document or something. If we're rendering server side, it's going to probably turn into HTML, and we have templates for that. In the case where there is a front end and back end, well, okay, so there is going to be a back end, because again, you got to store your data somewhere. You've got to check passwords and stuff somewhere. Where there is a front end framework that's doing a lot of work. Well, again, we have the data that's in the client and the data that's in the server, and there's this back and forth between them. Again, JavaScript objects here, database rows, or Python, Rails, whatever objects there. How do we map between those two? And that's, it gets described variously as like data binding or JavaScript ORMs. How do we take the data from here and turn it into useful data over there? Or for the front end frameworks, we have the data that we got from the server. How do we show the user? So this is the client side templating or data binding or whatever. Or in the other direction, the user types some stuff, right? They're going to create a new object, create an order, or enter a new contact, or whatever it is. Okay, they've done some stuff in some HTML controls. How do I turn that into a JavaScript data structure, and how do I send that back to the server? So there's all of those things that, again, in various ways, like the front-end frameworks are somehow not as universally complete, I think. Like they all do some subset of these, but not maybe all. And then there's all the other things. A few groups talked about sessions and user authentication that are baked into most of these backend frameworks. But that's good because I don't want to worry about it. Like I don't want to send a cookie and then create the table in my database that records this cookie is this user or has the, wants dark mode or whatever else is going on. I probably want the framework to help me at least. As a programmer, I need control over what's happening, but I don't want to take care of every detail if everybody has that same problem to solve. So programming in the modern world requires a lot of time in the documentation. And I see a lot of programmers who maybe don't have a lot of experience doing this. A Stack Overflow is not a repository of all knowledge. Let's put it that way. If what I want to do is keep track of, okay, does this user want light mode or dark mode and save that in their session? Well, maybe I can find a snippet for something like that. Maybe I just have to understand what a session object is and how it works in my framework. And maybe that's going to require some reading comprehension and knowing where the reference documentation is. Don't go to Stack Overflow first. Even if you go to Stack Overflow first, go to the docs second. Go to the reference documentation if you don't find the answer in some here's the problem. Again, I feel like increasingly, like over the last maybe 5 years or so, I see students become like anxiety, like it rises in them when they can't immediately Google and find a snippet of code that solves their problem in Stack Overflow. You got to know how to program, and there's no way around it. And not all problems are solved in Stack Overflow. And even if all of the common problems that get asked in assignment questions are, the ones that you get paid to solve in the future are not. So, well, I think the framing problem here, right? Like the problem that I used to frame the technology evaluation was, how do you choose? Like, do I want to use Pyramid? Do I want to use Chicago Boss? What about Laravel? Which one is the one that I should pick for my next project or for your project in this course or whatever? Well, I guess first thing, which category are we? Are we talking about a client-side framework or a server-side framework? You don't need a client-side framework. There was discussion in the lecture chat, I don't know, several weeks ago. Like if I was being honest, my favorite client-side framework is, why do I need a client-side framework? Who cares? Web browsers are already capable of producing HTML. So am I. What's the client-side framework for? But I'm willing to admit that is old man yells at cloud web development. So what do I want? Do I want one of the, how do we compare and contrast them? Hopefully the presentations, helped a little bit there. And then this is the thing that really does bug me. I think a lot of the like tutorials and stuff for your Angulars and Reacts and Views, it's like there's just magic data, right? You can just somehow magically will data into existence and look how easy and fun our front-end framework is. Well, the data has to come from somewhere. It has to be stored somewhere. You need a server, you need a backend server, you need backend code, which is another reason I'm not super wild about the client-side frameworks. It's like, I already have one framework. I'm already going to worry about all of these things there and what data is there, what tables have what columns or what objects have what fields. Why do I want to say that all over again on the client side? I don't know how to quantify this, but again, I've looked at some frameworks in the past and looked at the tutorial and thought, wow, that's really good at making a to-do list app in the tutorial, but I don't want to create a to-do list app. I have a different problem. And my problem has this complication where it's not just straight like this piece talks to this piece, this piece, this piece. It's like I have those pieces, but then this one has to inject some data over there, or I have this library, or what happens when things are not as simple as the tutorial? I definitely have this feeling that there's some things down this list where it's like, you're good at the simple case, and the complex case doesn't really get solved, or isn't easy, or you have to do a lot of black magic to actually do anything outside the common path of the way apps are supposed to work. Again, some of these feel a little narrow. I mean, even something like Redux, it is like, explicitly, its job is to be this like data management layer on top of React. And there's a similar thing for Vue. Is it Vuex maybe? Do you need that? Is it useful? Do you have that kind of problem? Maybe. And if you don't have that exact kind of problem, can it do the thing you do have? Can it solve the problem you do have? Something I talked about, it was 3 or 4 weeks ago now, like when I was talking about security. This is a big thing for me, that I know people write code that is, they solve things the obvious way, right? The thing that requires the least keystrokes, the least lines of code, the least distinct concepts from the reference manual, that's usually the thing people do. Is that a secure thing or not? And frankly, if it's not, I'm not using that framework. Like, so, like Rails version 1, like, so that, not a problem for modern Rails, but again, like the templating language in Rails 1 did not automatically escape. You had to explicitly escape everything if you wanted, less than turned into ampersand LT semicolon, bad default. And they fixed it long ago, but that would be a deal breaker for me. Again, is the code nice? Do you like reading this code? Does it produce beautiful, functional, easy to maintain code or not? I don't have an answer for any of these questions, really. There's a reason that 21 groups did not have any problem finding interesting topics to talk about. If any one of these was perfect, we wouldn't have all of the rest of them, right? If there was simply perfect front-end framework and perfect back-end framework, this list would have 2 things on it and the technology evaluation would be boring. None of them are that. None of them are perfect. They're all good at different things. The same reason we have a lot of programming languages and everything else. Okay, moving on a little bit. I guess one of the things that I didn't say there, right? The framework should help us. It should make it so we can get more useful functionality written well, good code, secure code, but quickly. I really want my framework to help me. And like something like Java Spring, I am not convinced that Java Spring does this part very well. It's hideously complex. And I guess if I was starting a project that was going to have 100 developers on it at, some large company, maybe that level of complexity pays off. But, if what you're going to have is 2 developers working on something, I don't think this is your choice. Whereas, I don't know, Flask is, again, designed to be quick to start. Maybe it doesn't have as many features as Rails and Django and I don't know, like a Laravel and stuff, but it's quick to start. Probably if I had 100 developers working on a project, Flask is not the one. It's going to depend a little bit. But anyway, I also want the thing to be fast. Like I want my website, when the user clicks on something, I want them to get that response back quickly. Again, a few weeks ago, there was some sort of like, you want like a 2, 3, 4 second absolute, upper bound on user click something and they have the page back and drawn on their screen. So, okay, network delay is going to take some of that. The web browser doing its thing and drawing on the screen is going to take some of that. But then we, on our side of things, need to do that as well, like on the development side, and the framework hopefully can help us there. So, I mean, I guess the story I just told there was latency, how long between requests coming in and response going out. but also throughput. Just like I don't want, if it was possible, I would like to pay for one server to do all this work and not 5. So I would like efficiency in kind of both senses there. So some of this is going to come down to things like programming language and runtime environment, the Java virtual machine versus the Python virtual machine versus the Ruby, the Rail, Ruby's the programming language, the Ruby runtime environment or whatever else. And then there's you as a programmer, like, don't do a lot of stuff. Don't write inefficient code. And maybe the framework can help us. So in order to sort of tell the story, I guess we have to run the code. And this is something that on exercise, is it 7, 8, those ones? 9, somewhere in there. 7, I guess, definitely to like deploy the thing, and then 9, deploy the thing better. You're sort of looking at this, and it's, well, when a request comes in, how do we make my code run and generate the response, and the response gets sent back with as little extra stuff happening as possible, right? I want that whole process to be quick. So in order to make it quick, I need to sort of keep my code running, right? I need a process sitting there that's running my Python or Java or Ruby or whatever code, so that when the request comes in, I don't want to start up a whole new process. So that's step 1. And then I have a web server that's going to, the front end web server, the thing like Nginx or whatever, that's going to have to actually talk to the user, the outside world, and then talk to me, my code, and get everything running. Okay, let's see if I have a tablet and I'm sharing a screen to my computer, and this never goes well, but let's see if I can kind of get things working here. So also I guess I have a question of space management here. Anyway, so first things first, here we have a user, and somewhere back here there's my code doing whatever, the stuff that I wrote. So I think my question here is, like, how do we fill in this gap? Like, what are the actual things that are running here as your code is actually doing the thing on the server? Okay, well, I'll fill this in as we go, I guess. No, what we do now, we know that we have something like Nginx, say, front end. So we have a front end server that the user is going to see, right? So we're going to have some HTTP, let's say HTTPS, because let's say we've probably turned that on. And so this is something like Nginx, right? That we've got up here facing the user, talking HTTP, public facing. And then somewhere back here, we're going to have like our application code. And let's call it the app server. So this is where the code that I wrote, or you wrote as a developer, is going to get run. And this is what was sort of on this slide here. So how do we run Python code? Well, it's something like WSGI. Somebody mentioned WSGI during the tech eval. But maybe I made that up. You know what? Maybe I'll. So Node is also in this category. So I often have people ask, like, oh, Node.js, that's a framework? No, really, Node.js is a way to run JavaScript code on the server and speak to the the front end. So Node.js is by itself an HTTP server, but it's not an HTTP server that's meant to be sort of looking at the outside world. It's there for sort of this purpose. One of the ways that you could speak here is HTTP, right, between the front end and back end server, but it's kind of a private conversation. It could be something else as well. WSGI, so WSGI implementations are things like Unicorn, UWSGI. Rack is implemented by Unicorn. Again, Node.js is its own sort of thing for JavaScript. Netty and servlets are ways for Java or JVM-based code to speak to a front-end web server. And that's what these things are doing out here. So it's, I have my code. How do I make my code run? And how do I arrange the world so that the front-end server can talk to my code when the time comes? So from the programmer's perspective, all of those things have basically some way that you know, some function that you have to write, some object that you have to subclass or whatever it is, that is, when a request comes in, I want my code to run, I will return a response object, or I will generate a response, or whatever, however it's phrased in your technology, but something like this. It's request comes in, response goes out. And you fill in the code in between. And well, web happens, I guess. Right, like I said, so there's various implementations of these things. You know, as a Python programmer, you might be exposed to WSGI. There might be another framework layer in between you, like Django implements WSGI. Flask implements WSGI, Rails implements Rack, Express speaks to Node.js, then these things run, they speak to the front-end web server and get responses and requests flowing. Right, so I guess this is the thing I just drew, right? So the user speaks to a front-end web server, something like Nginx. Right, static. I did not mention static resources over here, did I? So I guess the story that I told is kind of assuming dynamic content. So we also might, you know, we have our CSS, JavaScript, fonts, images, all of that stuff that are just static files. So we don't need to run our code for that. They're just probably files on disk. For dynamic content, we have code for that. And it's this communication that, again, I think this is part of the confusion. And again, because Node.js does present an HTTP server, and so does the development server for Django and Flask and the web, what's it called? Whatever the development server is for Rails. All of those kind of look like a web server, and they look like, well, what do I need all of this other mechanics for? And well, this conversation could be done with HTTP. It could be something else. It kind of doesn't matter very much in a technical sense, as long as the front-end server and the application server agree on how that request and response are going to be communicated. And HTTP is one of them. How'd I do? How does my diagram compare to this? Poorly, I would say. But yeah, we have these things happening, and I guess, right, the thing that I haven't really drawn in here is there's again, the framework that you think of as being here, the thing that you as a developer are going to spend your time on, Django, Rails, etc. And those, somehow these are going to speak to each other. Probably that's taken care of as part of the framework implementation. Like there's something in Rails that knows how to speak to like passenger or whatever, or it knows how to speak rack to passenger. But you spend all of your time here. And again, I think the part of the reason I feel like I'm saying a lot of words about this is it's very easy to do a tutorial in one of these frameworks and not realize all of these pieces are in play, or why is the development server not appropriate for the outside world? Well, it's not supposed to be very fast, and it's probably like the development server for all of these will serve static files slowly. You really want your front end server to be the one serving static files. It's much better at it. It's faster. You know, I don't want Ruby code running in order just to send a JPEG image to the user. It also means that like debugging this can be a pain. Like if you have a deployment that you think you have a front end server that should work and it's not, well, all of these things might be going wrong. It's kind of nice to be able to at least know what's going on to try to debug. Right. And I think this is mostly a thing of the past, but I guess the question here is how many of these things are integrated into like a single process? Like probably the application server and framework code, they're together. They're a Ruby process, a Python process, or whatever. For PHP, like traditionally, at least PHP was run as part of Apache, and it was like front-end server, back-end server framework. They're all one process. There's a lot of mess for like, there's a lot of permissions problems, like what user runs that process, questions. There's memory usage problems with that, because then you have a front-end server that sometimes it's serving static files, sometimes it's serving PHP, or it's running PHP code, and you have the memory usage of all of them no matter what. So this is kind of fallen out of fashion, just because it turns out you want to separate these things, and you don't actually want them all running in the same process, just for like architecture, speed, deployability reasons. And I guess the thing that the thing I don't like about front-end frameworks is I very often see people very confused about, like, I guess the way I've drawn it, the front-end framework is out here. Like, in fact, maybe I should like forget that that's called user. Maybe it should be called browser. Because, okay, there's a lot of complexity here. It's not just a person with eyeballs staring at a screen. It's a web browser running JavaScript code, and my front-end framework is all up here. And so maybe what's coming across the wire here is maybe it's HTML. And I think, again, I tend to tell the story as if it's going to be HTML, but it might be JSON. It might be, there might be I guess might be a WebSocket connection. I don't, in some sense, care which one's which. But I think a lot of people get very confused about, like, well, even just like I wrote a line of code, where does it run? And again, especially when you're using like a JavaScript-based framework, everything's JavaScript, right? The code that runs here is JavaScript. The code that runs here is JavaScript. When you write a single line of code, is it this code or is it this kind of code? As a developer, you kind of have to know. And it's very easy unless you really know the architecture to keep track, to be honest. So the things that the front-end frameworks are doing for you is managing like what's happening over here. And that's great. Like, I don't want to discount that and say it's not important, but there's still fundamentally a network connection and some kind of data flowing between the web server and the client, you can debug that, say, by looking at the HTTP conversation. And it could be very hard to do that because there's just layer after layer of complexity, some of which I think are genuinely poorly described. And the documentation just makes it seem like, oh, it's just magic, right? You write a line of code over here and something happens over there. Are we still okay? There's a bunch of communications in between here and there. Okay, so once we've got our code running, so again, we have some picture like this. Again, I'm going to talk mostly about the backend framework here. So I'm imagining the code that I write is mostly my app did crash. Okay, well, let's hope I don't have to draw anything for a little bit. So, right, pardon me. I have my code running here. This is where probably as a developer, I'm in control of how fast things are going to go. Is this fast code? Is it slow code? Does it take 1/10 of a second to run? Does it take 5 seconds to run? That, of course, is going to affect the experience the user has. So all the work that I'm doing, again, in this sort of backend application side of things is where, I guess, as a developer, now we have the chance to go faster. So I guess the question here is, what do I have to do to create a response? How much of that can I do ahead of time or avoid or whatever else? So for something like Ruby on Rails, I think Rails still does this, and I don't know, somebody correct me if I'm wrong in the chat or something, but in Rails, the database, like the model structure is defined by the database, right? So when Rails starts up, it has to look at the database and say, well, what tables are there? What columns are there? What types are those columns? And that implies the model structure. And I think that's still true. It might have moved over to Ruby code. If not, it was true. Like there was a situation in which the startup was a huge amount of work because you had to you at least have to connect to the database server. Maybe you have to do a bunch of inspection. Maybe you have a config file to read, all of those things. I don't want to do those every time a request comes in. And that's part of the reason for some of the architecture that you see with these backend frameworks. And, I'm not a huge Java fan, but credit where credit is due. The Java servlet, which again is fundamentally a way for Java code to be structured so that a web server, Tomcat or Jetty, can, when a request comes in, call the appropriate logic in Java so the response comes out. And for some reason, they call it a servlet container. Servlet container just means web server, like that runs Java code. But I'm creating a class called servlet example that's a subclass of HTTP servlet. So I inherit a whole bunch of magic from that, and that's great. But then I have this very nicely, again, I like this architecture because it's very clear. How do I get things set up? Like you almost would think of this as a constructor, even though it's not a Java constructor, and a destructor. So I do this once. Again, connect to the database, inspect the database, read the config file, whatever it is. Get ready. Do that once. And then when a request comes in, well, I get a request and I get a response object that I have to dot write to or dot set header or whatever the methods are. So I can move as much work as possible here and do it once, and then the work that I absolutely have to do to generate a response, put it there, do it n times. Yeah, it is a nice try. And again, it's just a very clear description of what's going on. If you write WSGI code by hand in Python, and you probably aren't going to write WSGI code by hand, but somebody did, right? Somebody, the Django or Flask or whatever developers wrote code like this. That's like, okay, well, we'll get set up and we will somehow connect from our code to the web server. I think this is a more development style thing, but whatever. Every time a request comes in, this function gets called. So it's the same kind of structure. It's a little less clear to me, I guess. Like I basically have this callback function for the event, that is request comes in. But I do some stuff and I return the result. So again, this code runs once. Sorry, like this code runs once. This code runs as once for every request that comes in. So I get a bunch of work out of the way outside. Okay, well that's good. Like I guess the question is, what else can I avoid? What other work can I not do in order to actually generate a response? And at this point, maybe this just becomes, I have to be a good programmer. So this is something like, well, maybe I can just avoid altogether, right? There's content that I could send with an expires header and just not get the request. Or maybe there's a situation where enough work has to be done. Like, once I start this do get method, I know I'm in a situation where a lot of work is going to happen. I have to make some big expensive thing. Maybe I can check, if it looks like the user has an up-to-date copy, return a 304 not modified and avoid the heavy lifting. And like I think I said a few weeks ago, like I don't usually do that. Like I don't think that's usually worth it, but maybe if it's a really heavy request response, you need to. Maybe the technology can help. So remembering that we are fundamentally dealing with HTTP here, web accelerators, reverse proxies, or caching proxies, all of these can maybe help. Maybe we have this kind of situation. So I guess I talked about a caching proxy server, again, several weeks ago. This is a shared cache among many users, and I thought I had a picture here. Okay, I do. But so this scenario is the code that we're writing as web application developers is in a language that tends to not run very fast. Those who have taken 383 with me know I hate to say that sentence. Like Python can run very quickly, so can Ruby, so can PHP, with appropriate like just-in-time compilers and stuff. But on average, usually they do tend to be slower. So I want to avoid this code if I can. The work is fairly heavy, right? So rendering a template, is a huge amount of string processing fundamentally. Object relational mapper, putting together the query and going to the database and turning that into objects can be a lot of work. Maybe again, just the work that I'm doing is heavy. So we talked about, again, like caching proxies a few weeks ago, and this was the picture that the user's end of things has the cache in it. So again, proxy.sfu.ca, I believe is the domain name for one, sits here. And we can choose to use it, when on campus if we want. Maybe there's some policy on the network that forces us to, but whatever. Everybody here, again, on campus or whatever, can share that cache so that we don't all have to download this image or whatever it is. It can come from a local copy. But this isn't a real, this is not a common setup because not a lot of people configure themselves to use a proxy server. But we can change where the boundary is there and say, well, I'm going to move the proxy into my side, and then it becomes a reverse proxy or a web accelerator. And this is, I know I have content that can be cached. I'm going to cache it on my side because it will be faster to retrieve it from the cache than it will be to retrieve it, or rebuild it with my PHP code or whatever. So that's the story. It's, again, basically the same picture, but instead of the cache being on the user's end, the cache is on the server's end. The benefit is that now everybody's going to use it, right? Like fundamentally, I'm advertising this reverse proxy as example.com. You're going to, every user is going to hit that because that's the web server that's facing the outside world. So if I can cache there and the cache is fast and this all works out, that should be a huge speed up. So something like Wikipedia, I think, is a good example here. Wikipedia does cache. Like they do have this set up. They use, at least last time I checked, they were using Squid as a reverse proxy or accelerator. So, okay, we have a cache coherence question all of a sudden. Maybe something like this, right? Wikipedia might just say, okay, whatever, we're going to cache for 60 seconds. Like basically, we're going to set an expires header that is 60 seconds in the future every time we build a page. So that means that when, okay, generating the page, so turning wiki text into HTML, again, it's a bunch of string processing and parsing and stuff. I would like to avoid that. I can do that once every 60 seconds, right? Because the ratio of reads to writes is pretty good for, pretty high for Wikipedia. Most people read pages, relatively few people edit pages, or relatively few requests, I guess, involve editing a page. So cache it. And okay, maybe somebody edits a page and then for the next 59 seconds, a bunch of people are seeing the out-of-date version. Yeah, if I was Wikipedia, I would say that's perfectly reasonable. I'd be fine by me. And the trade-off is, instead of generating that page for, I'm literally trying to think of a famous person page, instead of having to update it every single time that request comes in, because again, everybody has to check that person's birthday because there's some news story or whatever, you generate it once, cache it for the next minute. That should be much, much faster. Varnish is like, if I was going to choose one of these, Varnish is probably the one I would choose at the moment. It's designed to be fast. It's designed to be, like solve this problem well and kind of get out of the way. And it's good at it. And there's a description somewhere of how they, the sort of architecture of it. It's a really good description of just like systems programming in the modern world, but that's another story. Nginx can pair with memcached. There's a module for that or whatever, and it can do this job where you basically just say, okay, well, front-end web server, you're allowed to cache. You do that if you want, and it will then look at the expires header that gets sent from the back and maybe cache. Okay, is my thing working here? Maybe. Damn it. It's bringing up the keyboard crashes this app 100% of the time. Anyway. Yeah. Anyway, so maybe what we're doing, you can see enough of the diagram. Maybe what we're doing is sort of either inserting the reverse proxy / web accelerator in here, in between the front-end server and the outside, or maybe we're incorporating it so that these two things are the same. I'm going to pause the recording and uncrash my app. Okay, so how do I, can I like, is there some way to erase? Okay. So, right, maybe what we're doing is inserting in here. So we have HTTPS still, and we have, this is, by the way, this is actually, like, I know it looks like this tablet isn't working and my demo is going well. This is how this always goes. I am doing this knowing that failure is just around the corner at every given moment. So I have a reverse proxy here. Again, maybe the front end server and the reverse proxy are actually one thing, maybe not. Maybe the reverse proxy and a load balancer are the same thing. I'll get back to that as well. But again, bunch of possibilities there. And if caching makes sense for you, that's great. This article is getting a little bit old here, but I do like it as a description. And it's basically like, in your application server, you can cache the page. And I guess, apparently for this architecture, it's not that Nginx is looking at the expires header. Maybe I lied back there. It's that in your application server, you can say, hey, I'm going to cache this URL, shove it into the cache, and then Nginx always checks, like, hey, do you have this URL for me? Oh, okay, great. Or do you have this URL for me? No. Comes back to your application code, generate the page, you decide to cache it and send it back. On this page for this person or this site, whatever it was a 4x speed up. And if you can cache a non-trivial amount of stuff, yeah, that totally makes sense to me that you're getting a huge speed up with that little architectural change. The other thing that can happen, like I mentioned back there, your Wikipedia page might be out of date for 60 seconds. If you do this thing and you say, okay, here's a Wikipedia page, cache it for the next 60 seconds. Well, maybe not. So because this cache is now on your side, you're in control. If you want to manage what's being stored in that cache, you can. So like Varnish offers this like non-standard HTTP where you can say, instead of get or post or put or whatever, you can say purge, special message to the cache that says, hey, just forget this URL, please. So again, if Wikipedia was doing something like this, it would be like the way that the backend code handles an edit, right? So when somebody edits a page, click submit, store that record in the database, record the logs, do whatever else, and send a message to all of your reverse proxies and say, yeah, hey, forget about that. Like that page that you had cached, remove it from your memory, and then next time a request comes in, we'll regenerate it. So again, because things are now on your side, on the server side, you have a little bit more control. In the story where it's a straight up proxy server on the client side, there's no, like, you can't contact every client proxy in the world and tell it to forget a cache, but you can contact everyone in your server farm or whatever. So caching's hard. And again, I think we have these two options realistically of, do we want to just say, well, cache it for a minute, and if I'm a minute out of date, that's okay. And depending on the content, that's totally acceptable. Or cache it forever and invalidate the cache as appropriate. And like I talked about, I talked about asset management again a few weeks ago, that where you can do this kind of thing where, again, like this file is generated, like this content is generated from a bunch of sources, whatever they are. It can be done on demand. But the promise here is that the URL changes if the content changes. So this resource can be cached forever. That's totally fine. If the content changes, the URL will change. Effectively, that's a cache invalidation because we're just pointing at a different cache key. Or again, purge from the cache if it's on your side of things. Caching's hard. Cache invalidation is hard. I believe this quote is about CPU cache, like L1, L2 cache, but it's still hard. Deciding how long to cache things is hard. Invalidating them when they change is hard. The speed up can make it worth it. The other thing that's happening, again, the thing I talked about several weeks ago when talking about proxy caches, again, if you have a shared cache, and in this situation, you definitely have a shared cache, we have these headers that let us deal with that. The vary header that says if people have a different accept language header, we're going to send them different content. If different users all get different content, this shared cache is not going to be very useful. But hey, not all content is going to have this property, but some will. So the architecture gets a little more complicated. The way we deal with it gets a little more complicated. We have to make sure, if we're doing translations, if we're doing different things for each user, we have to say that. It has to be part of our response. It probably should have been anyway, but we really have to now. Varnish has a lot of cool tricks. Like one of them is this, where you can kind of rewrite the headers as they come in. I'm not going to go through that code. I don't think it's worth it. But because the cache is on the server side, you're now in control, and that control can be cleverly used, I guess. All right. Where content is actually dynamic. So again, this is something like not Wikipedia. This is something like, I don't know, the front page in courses, right? So when I go, yeah, there's nothing private there. When I go there, right, we're all going to see a different thing on that page because we all have a different set of courses that we're going to look at. That's not something that makes sense for caching at the HTTP level. Because we're fundamentally going to have to put very cookie on that response. We're all going to get different content. A reverse proxy is just not going to be very helpful. But I'm still programming here, right? We still get a chance as a programmer to do things more or less cleverly. So things like memcached and Redis are well, they're cache servers. They're, in some sense, they're a database. In some sense, they're a key value store. Fundamentally, they're a really, really fast key value store. And I guess by key value store, I mean hash table or dictionary or lookup table or whatever. They're a really fast way to say, do you have this fact? And they come back and say yes or no. So it makes them a really good tool in this sense, where, you know, have I already generated this data structure? Oh, then just give it to me, or no, you have to generate it yourself. Do I need these open? Maybe I'll keep these open. Yeah. But so maybe there's something like on every page, like, I don't think in this case it's a huge amount of work, but like this top bar with the, whatever divs and headers and, this form that is the search and this bottom bar, those are the same for everybody, right? So there's no difference in what is sort of above this line for my page or your page or whatever. That part of the response, that part of the template could be cached. And again, if it's kind of a noticeable amount of work to generate that string that goes in that spot, maybe this makes sense. Or the example here from the Rails docs is like, I have a product catalog. I have all of the products on my site, and each product has this little box that displays it. Well, I don't want to regenerate the HTML fragment for that piece of the page. I will cache it. So this is just the template for each product display. And I could maybe just do this. But the caching insertion here is saying, well, you can cache this fragment of HTML, and if I have to display this box again, if I'm trying to display this product again, pull it out of the cache. Don't do all that string manipulation to generate it again. So again, imagining that there's something kind of expensive being hidden there. And that's a fragment cache, and probably that's exactly the same code that you can do in Rails. Is it worth it? Sometimes. Or in Express, so this is application level, but caching an entire URL. So again, maybe this is in some way or other, this content is expensive to generate and the same for every user. So what I've said here in sort of either case is cache it for 5 minutes or 120 seconds, however you want to think of 5 minutes. Maybe that's worth it. And like for the Django one, I know this will it will cache it internally. So it will cache it like on the application side, and it will also set an expires header 120 seconds in the future. Again, if what's hidden here is expensive, that can be worth it. And I've definitely done that on pages. It implies that, you know, if something does change 119 seconds from now, you're out of date, but maybe you're willing to take that trade-off. Or even lower level, if you're just a programmer, like again, we're just programming here. Let's not forget that programming is what's going on. You can write code like this, right? So I have the actual thing that's really hard to do or requires a whole lot of database queries or a bunch of string manipulation or whatever it is. And I have a wrapper around it. So this is a function you're actually going to call when you need this value. And the logic is basically try to get it from the cache. If you got it from the cache, great, there it is. Else, do the hard thing, right? So it wasn't cached, I have to do it, and then put it in the cache for the next 5 minutes. So the implication there is that this function will never be called more often than once every 5 minutes. That's, again, in the case where there is some, again, and I've had to do this, where it's just, you know, you get yourself into a situation where the logic that you have to do to build the result you need is just really complex and really ugly. Maybe it's worth doing it. And as a programmer, you can then choose, like, where do I want to do this? Do I want to do it at this function call, this function call, this function call, and choose one that is, I guess, a pure function, right? Where the result just depends only on the arguments. So, you know, if somebody else calls this function with these arguments, it's always going to be the same result. So in some way here, we have another data store. And you know what? We didn't have the first data store in the picture. Let's see if this is going to work. Oh, I have not managed my my real estate very well here. But I have a database. And so again, my code is talking to the database, and this is just your basic, you know, your MySQL or whatever. So you're going to store data there, and that's probably the canonical definitive copy of whatever data. Effectively, if I have a cache here, what? Why is undo anyway? If I have a cache here, effectively, I've just denormalized my database. I have a copy of some facts over in the database. I have a duplicate copy of those facts over here in memcached. All of those things that I remember from the database course about normalized and denormalized data, I've just broken that rule because I've denormalized. Again, maybe it was a good idea because of performance, but I maybe have to remember that was a trade-off I made. I have made my application code more complex in exchange for that denormalized data that will speed things up. So yeah, I don't think this is an every line of code kind of thing, but I do think, and again, the reason I'm spending a little time on it is it's a huge speed up when it makes sense. If you do have, again, I've got to join 7 tables together and do all of this filtering and then go through the records in my code and find the ones that have some weird property and then generate the 10 lines of actual response. Maybe I can cache it. Maybe I can avoid that most of the time, and I can invalidate the cache when I need to, or just the thing doesn't change very often. So something like in courses, like this page is, there's markdown code or something, right? Like there's markdown code in the database for this part of the page. It has to get turned into HTML. That is cached. And it's cached in a way that, you know, sort of like this, which is, you know, turn the page content into HTML is cached and I think invalidated. So I think it's cached for a relatively long time because, again, when somebody edits a page, we know what the cache key is. We can chuck it out of the cache, remove it from the cache, memcached or Redis server when the time comes. Or maybe there's data that only gets refreshed overnight, right? There's just data that changes at 6 in the morning because that's when you import some external data source. So cache it until 6:01, and then you can regenerate it once a day. Those kinds of things sometimes are very much worth it. And again, the sort of turning Markdown into HTML, it's not super expensive, but it's enough that I suspect it does make a human visible difference on how fast that page loads sometimes. Okay, that's a good spot for a break. I'm going to take one, come back, talk some more about server architecture, how to deploy a thing and make it go fast. See you in a little bit.